Hello, myself Daksha Patel, working as an assistant professor in computer department at Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. Now today we are going to learn about part 5 of unit number 2, in which we discuss about heap sort. Now first of all we give the introduction about heap sort, then we learn the example of heap sort and then write the code for heap sort and find the complexity. Now first of all we see what is the heap. A heap data structure is a binary tree with the following two properties. The first property is it is the complete binary tree, means each level of tree is a completely filled except possible at the bottom level. At this level it is filled from left to right. See in the pictures, first of all A, then B and C, then D and E, and here F at right side. Now it is known as a binary tree. Now what is the complete binary tree? First of all we root A, then child, left child B, C, then D, E, then F. Here it is known as a complete binary tree because it is filled from left to right. Here the difference, it is right node, C has a right node, and here C has a left node. So that is the difference binary tree and complete binary tree. Now the second property is it is satisfy the heap order property. The data item stored in each node is greater than or equal to the data item stored in its children node. Means the root node is greater than or equal to the data stored in its children node. Now see here with the example, first of all 9 is the root, then left and right child is 6 and 7, then 6 is in 2 child, left is 2 and 4, and then 7 has a 1 child, 8. Now here second example 9, 6, 7 is a child and 6 is in 2 child, 2 and 4 and 7 and 1. The first figure is not a heap order property because here the 7 is a greater than 7 is a smaller than 8. So is a not heap. Now the second figure see here it satisfies the heap property at the each level 9, 6, 7, then 6 has in 2 child 2 and 4 which is less than 6, and then 7 has in 1 child 1 which satisfy the heap property at each level. Now next the array representation of heap. Now how to represent a heap in array. Now an array A that represent a heap is an object with the two attributes. The first is the length, which is the number of element in the array, and the second that is heap minus size of A, that is the number of element in heap stored within the array A. Now we see it with the help of example. First of all 16, then we put the 16 in array, then 16 has a 2 child 14 and 10, then we put the 14 and 10 in array, then 14 has a 2 child 8 and 7 we put here in the given array, then 10 has a 2 array 9 and 3 we put it in array, then 8 has a 2 child 2 and 4, and then 7 has a 1 child in 1. So this represent array representation of heap, and this is the heap structure. Now in array A that represent the heap, there is a two property length A, that is the heap minus size of A. For any node I, the parent node is I by 2, and for any node J, the left child is 2J and the right child is 2J plus 1. Now we see with the help of example. For node I equal to 4, the parent node is I by 2, means I is equal to, we take the, for example I is equal to 4, then for parent node is 4 by 2 is equal to 2. Here I is equal to 4 means 1, 2, 3, 4. Then the 4 has a parent node is I by 2, that is 2. See here. Now next, for node I is equal to 4, the left child is 2j, and the right child is 2j plus 1. So the left child is 2j. What is the value of j? 2 into 4, that is 8 here. And right child is 2j plus 1, that is 2 into 4 plus 1, that is 9. So left child is 2j and right child is 2j plus 1, that is 4 into 2 plus 1, that is 9. So this is the property of heap. Now there are two types of heap, that is max heap and min heap. Now what is the difference between max heap and min heap? Now in max heap, the value of root node is greater than or equal to its child. We see it with the help of example, that is 9, 6, 7, and then 6 has a 2 child, 2 and 4, and 7 has a 1 child, 1. Here satisfy the root node is greater than or equal to its child. Now next, that is min heap, in which the value of root node is less than or equal to its children. Now we see it with the help of example, that is 1 is a root node which is less than its children, that is 2 and 4. Now 2 has 2 children, that is 6 and 7. 6 and 7 is greater than its root node, and 9 is also greater than its root node, that is known as an min heap. Now heap sort. For create the heap sort, first of all we build the complete binary tree using given element, and then create the max heap to sort the ascending order. Once the heap is created, we swap the last node with the root node and then delete the last node from the heap. Now for that, we repeat the 2 and 3 step until our heap is empty. Now here we sort the given element in ascending order with the help of heap sort. Now first of all, the given element is 4, 10, 3, 5 and 1, and the index is starting from 1, 2, 3, 4 and 5. For that, we first of all build the heap. First of all 4, then 10, then 3, then 5 and then 1. So once the binary tree is created, we convert into the heap. Now here we create the max heap. What is the max heap? The root is greater than its child. So here 10 is greater than its root node 4. So we need to swap it here. Create the max heap. 10 is greater than 4. So we swap it. We also swap in array representation, and also swap in here. Now here 5 is greater than 4, so we swap it, and also swap in array representation. Now see here, our max heap is built because root node is greater than its child. Now for heap sort, swap the first and last node and delete the last node. Here last node is 1. Now we swap it with the root node. And then delete the last node. Here we delete the last node. Also we swap in array representation here. Now we delete from heap. And then repeat the second step and third step. Now what is the second step? To create the max heap. Now what is the max heap? The root node is larger than its child. Here child is larger. So we swap it. Here we swap it. Also we swap in array representation. Now here also need swapping. We swap 4 and 1. Also in array representation. Now here our max heap is built because it satisfies the property of max heap, which is root is greater than its child. So now we swap the last node with the first node. Here last node is 1. Now we swap Also swap in array representation. Now delete the last node, that is 5. Okay, now again we create the max heap. So here children is larger than its root node. So we build the max heap. We swap it. So max heap is built. We swap also in array representation. Now we swap the last node with the first node. Now which is the last node? 3 is the last node. So we swap it. And then also swap in array representation. And then delete the last node. Okay. Now again we build the max heap. Here max heap is already built. So we swap the first with last node. And then also swap in array representation and then delete the last node. Now remove the last node from here because the element alone which is already sorted. So see here our array get sorted, that is 1, 3, 4, 5 and 10. Now we see the algorithm for heap sort. Now what is the input? One array is given and what is output? Sorted array. Now for that build the first of all max heap in which for I equal to length of a we down to 2 means divide by 2. Do exchange a of 1 with the a of I. Heap size is the heap minus size of a. We reduce the heap size by 1 every time and we heapify the heaps, max heap. Now for build the max heap, heap minus size of a, that is the length of array, and for I equal to length of a by 2 until we get 1. Do max heapify every times. Here we length of array, that is 6, so divide by 2, that is 3. 6 by 2 is 3, so I equal to 3 at, so we heapify it max heap because 7 is larger than 3. We swap it. Now again we divide by 2 down until 1. So I equal to 2 because 4 by 2 is equal to 2. So 9. Here 9 and 1. It's satisfied already. 9 and 1 get sorted. Swap. 1 is smaller than 9. So 9 and 1 get swap here. Now next 2. I equal to 2. Heap minus size of a, that is 2. 2 divided by 2 is 1. So I equal to 1. So 9 is larger than 4. Here we swap it with 9. So our heap max heap is built. Now how to sort it? For sorting, what we do? Exchange the last node with the root node and then we delete the last node. For that heap sort max heap for I equal to length of a down to 2. Exchange the first node with the last node and reduce the heap size by 1 and then create the max heap. Exchange the last node, first node with the last node. Here we exchange it and then delete the last node and reduce the heap size by 1 and then create the max heap. Now what is the max heap algorithm? That is left child is L, right child R. If L is less than N and A of L is greater than A of I, then largest is equal to L, otherwise largest is equal to I. If R is less than N and A of R means right child, is greater than A of largest, then largest is equal to R. If largest is not equal to I, then we exchange the A of I with the A of largest. Then build the max heap. Repeat the same process. Now here I is equal to 1. So largest left is equal to 2 and right is equal to 3. So satisfy this property L is equal to 2 is less than n is equal to 5. So 2 is less than 5, yes, and A of L, what is the value of A of L? That is 4. 4 is greater than A of I. A of I means 3. 4 is greater than 3, yes, condition is satisfied. Then largest is equal to L, so largest is equal to 4. L means at index 2 and value at index 2, that is 4. Then we check the next condition, that is R is less than N. What is the R? That is 3. 3 is less than 5, yes. Then A of R is greater than A of largest. What is the A of R? That is 7. 7 is greater than A of largest. What is A of largest? That is 4. So 7 is greater than 4, yes, condition is satisfied. Then largest is equal to R. What is the value of R? Index 3. So then check the next condition, that is A of largest, largest is not equal to I. Yes, here largest is not equal to I because 7 is not equal to 3. Then exchange the A of I with the largest. Then we exchange the A of I with the largest. So we swap it, 7 with 3. Now then we next apply the heap sort. What is the heap sort? Exchange the first node with the last node. Now exchange the first node with the last node and then reduce the heap size by 1 because the last node is deleted. So it takes the order of n minus 1 times. And this reduced size take the order of log n times to execute. Now, and this max heap, for building the max heap, it takes the big O of n log n times for executing. And this reduction of heap size which take order of log n times. So time complexity of heap sort, that is order of n log n plus order of log n into n minus 1 is equal to order of n log n. This is the complexity of heap sort. Now here we give the exercise for heap sort. Try to solve it using heap sort. Thank you.